Hi Precalculus scholars. This is what you will need in front of you for today's class. You should have gotten from your substitute handout 1.2b, so you'll need this. I also recommend a ruler, a pen, a highlighter, and some blank graph paper. So we're going to start off taking notes on blank graph paper, and we're going to talk about interval notation. And we're going to start off on a number line to keep it simple. So when I say interval notation, I mean the same type of notation we've been working with all week. So normally it looks like a bracket, an A, comma, and then a B. And last class we talked about how this A value is an X value, and this B value is also an X value. So at this point, if you want to pause the video to copy all this down, go ahead and do that. So how do we translate this first number line into interval notation? Well, I know I'm going to be trying to express this highlighted part as some X value to another X value. So the first X value in my interval is going to be -2. The second value is 0. And we can think of this as a number line. We can also start to think of this as an x-axis, which is going to be helpful for the next thing we do. So what I'm saying here is the highlighted part of my x-axis, or the interval that I care about, is from the x value of -2 to the x value of 0. For the second example, it gets a little bit more complicated. Again, I'm going to be converting to interval notation, and I'm going to try to express the highlighted part of this x-axis as some x value to another x value. So this is a little bit trickier because we know in math we always read from left to right, just like a sentence. And if I ask myself, what is the first x value, I kind of run into this problem because it looks like my number line, the highlighted part, is actually going all the way into forever. So I'm going to ask you to think about in math what happens when we go to the left on the number line forever and ever and ever and ever and ever and ever. And the answer is going to be -infinity. So a little bit weird, but the first number in our interval here, or our A value, is actually -infinity. So the highlighted part goes from -infinity, moving right to -2. Okay, this third example, I encourage you to pause the video and try it on your own before you watch the rest. And the answer to this third interval is going to be going left to right from 0. 0 is the first x value, and the second x value is going all the way into the positive direction to the right, all the way to +infinity. All right, so next I would like you to draw this function. And I'm going to ask you 2 questions about this function below. The first question is, where is this function increasing? And then, where is this function decreasing? So take a moment to pause the video and get this function copied into your notes. It has a minimum value at -4. It looks like the left side is decreasing and the right side is increasing. Okay, so as you can see, I've already taken the step of marking off the intervals of this graph. I marked off that everything to the left of -4 is decreasing, and to the right to the left of positive 4 is decreasing, to the right of positive 4 is increasing. So now I'm going to try to express this using interval notation. So the same thing I just did on my number line. The key thing is you'll notice that I only marked numbers on my x-axis. That's because for interval notation, I only care about x values, right? Because I'm only trying to go from A to B, which are both x values. So for my increasing interval, it looks like my function starts increasing at the x value of 4. And then looking along the x-axis, it looks like the function is going to continue to increase all the way up to positive infinity. And I can tell that because of this arrow here telling me that this function is going to go forever and ever and ever and ever and ever to the right on the x-axis. Then I can see that this function is decreasing. Again, I'm going to read the graph left to right. So moving from the left to the right, the x value that I start decreasing at is going to be negative infinity because of that arrow. And then I'm going to continue to decrease all the way to the x value of 4. And at 4 is when the function is going to start switching from decreasing into increasing. So this would be the mathematical notation way of answering this question. Perhaps you've also seen something like increasing for all x values greater than 4, decreasing for all x values less than 4. This also works, but in calculus there's a lot of interval notation, so we want to get comfortable with both of these ways of writing it. All right, so now is the time to take out your handout 2.1b. And I'm going to show you the first one. If you feel ready to go, consider just pausing this video and trying it on your own first. And this function is a little bit trickier because it looks like it starts off by increasing, then it's decreasing, then it's increasing again. So I'm going to end up with 3 different intervals. I'm not going to be perfect because I'm just using my eyeballs, but it looks like I can kind of estimate the function starts making this shift from increasing to decreasing at the x value of negative 4. So I'm going to mark off that interval of my graph. And then I have this other shift later on where the graph goes from decreasing to increasing again, and that is at the x value of positive 4. So I'm going to kind of mark off my graph, and I'm going to end up with 3 different pieces of my graph, 3 different parts that are all doing different things. So just to make it clear that I have 3 pieces that I'm looking at, I'm going to highlight that middle part. And then what I would do next is I would label this as increasing, this as decreasing, and then this as increasing. Positives, again, moving left to right, we have a positive slope, we're going uphill, negative slope, we're going downhill, positive slope uphill at the end. So now for my intervals, let's start with increasing. Since I have 2 different increasing intervals, I'm going to end up with 2 different notations. Okay. So from what x value to what x value is this function increasing? From negative infinity to negative 4, my function is increasing. So the key here is to just focus on the x-axis. So just like we did on the number line at the very beginning, the only thing you care about is the x-axis. From what x value to what x value is your function exhibiting a certain behavior. All right, I'm going to skip over here because that's the next time that my function increases. And you can see from the x value of positive 4 to the x value of positive infinity, the function begins to increase again. Right. And the last part of this problem is the decreasing interval. And you can see the middle of your function has a negative average rate of change from the x value of -4 to +4. So as you can see in your student directions, your next thing you're going to do is complete the rest of this handout. You have 9 problems, and then go on to the last part of your student directions, which is going to involve a reflection on Google Classroom. Have a great class, and I'll see you on Monday.